Welcome back. This is segment 2 of section 2.2, the probably almost certainly the last segment. I don't think I'll be expounding on too much here. And in general, as I said in the last one, this is usually where I end the first course unit, and there's generally a test after this. So I don't want to belabor it too much. I mean, it is kind of critical to be able to determine these exact values of trigonometric functions. And so I'd like to show a little bit more, a couple more exercises of that. I kind of considered it for a second, said, you know, maybe I ought to do a few more just so we really nail home the point. There's a couple tasks there. I'm going to work a little bit more on, hey, here's an angle, find the value of a trig function. But then I also want to talk about, we're kind of leading into in the rest of the chapter, which I do break up into another segment. We start talking about inverse trig functions, and the problem with inverse trig functions is that it's not the only answer. I mean, as you can see, you get the same trig value for multiple inputs, and so much like when you take the square root of both sides of an equation, you have more than one answer that pops out. Well, with trig functions, it's actually an infinite number of answers, but there's a way to kind of find what those, you know, a way to write all the answers in a way that's concise. It's not any value, but it's only certain values. It just so happens that there's an infinite number of them. So let's do a couple more here where we're trying to find say the trig value of an angle. Okay, so I think we're on page 4. So let's find the exact value of, let's say, sine of, let's say 585 degrees and cosine of 420 degrees. And let's make it negative just to make it interesting. Okay, so first off, in any one of these problems, you have to figure out what the reference angle is first. So, you know, if you're not real good at doing math in your head, we can just go through here and say, okay, well, 585, that's too big, is equivalent to 225. Now we know 225 is an angle in quadrant 3. So maybe I can make this chain of argument here. So sine of 585 is equal to the sine of 225, right? So therefore, theta prime is equal to, and remember in quadrant 3, it's whatever the angle is minus 180 degrees. We're not going to use this one, we'll actually use this one. So that's going to be 225 minus 180, or 45 degrees, right? So there's our reference angle. Now, so that will tell us then that the sine of 585 degrees is equal to, now let's think about the quadrant. It's in quadrant 3. So in quadrant 3, all students take only tangent and cotangent are positive, so everything else has to be negative. So it'll be negative sine of 45 degrees. So now we have to recall, what is the sine of 45 degrees? It turns out that it's square root of 2 over 2. So the sine of 585 degrees will be negative root 2 over 2. Okay, so let's try B. Same sort of idea. Cosine of negative 420 degrees. Well, we know that that's outside of, you might be able to figure out what quadrant that's in, but it's easier just to sit here with a calculator and whack it out. So let's see, 420, change the sign. So I'm going to add 360 to it. Well, I'm still outside the range. Add another 360 to it, and now I'm at positive 300. So this is equal to cosine of 300 degrees. Now, 300 degrees is an angle in quadrant 4. And similar, we need to come up with this right sort of formula. So theta prime is equal to, now remember, for quadrant 4 angles, it is, we subtract the angle from 360 degrees. So it's 360 degrees minus theta, which in this specific case is 360 degrees minus 300 degrees, which is just simply 60 degrees. So there's our reference angle. It's an acute angle, acute positive angle. Okay, so therefore, kind of following the same sort of pattern we have here, cosine of negative 420 degrees, it's quadrant 4 angle. So cosine, all students take classes. Cosine and secant are positive, so this will be the positive cosine of the reference angle, which is 60 degrees. Now, the cosine of 60 degrees, as you may recall, is 1/2. And so this value will be positive 1/2. Now, the positive sign is not necessary. I put them in there just to remind myself so that I'm not, sometimes you'll see stray marks and things that end up on a piece of paper and you're like, is that a negative sign? Is that some sort of, what does that symbol mean? So sometimes it's okay to be explicit. The positive sign is not necessary though. Okay, so this is just sort of a quick summary of how to do this a couple times so that you can see it. There are some problems in the text that make it a little bit more complicated where you have to do like kind of more than one at a time. So here's an example where you might have evaluate cotangent of 100 and let's say cotangent squared of 135 degrees plus tangent of 120 degrees. Okay, so this, it's not going to be a pretty number, but whatever. So remember, this is kind of, for whatever reason, this kind of throws people off because there's an order of operation that's going on here. The cotangent, the way to interpret this sort of symbolism is to say, first find the cotangent of 135 degrees and then square it. So not the other way around, like you're not, I mean, I don't even know what the other way around would mean, but you have to evaluate this first and then square it. So just so we recall here, okay, so cotangent of 135 degrees is equal to, and this is quadrant 2, so it's going to be negative cotangent of 45 degrees. I'm kind of finding the reference angle quickly, which happens to be equal to -1. And tangent of 120 degrees is equal to the negative tangent of 30 degrees, which is equal to the negative square root of 3/3. Okay? So when you put these, when you evaluate this, you end up with basically -1 squared plus a negative root 3/3. When you square a negative number, it becomes positive, and so you're just left with 1 minus root 3/3, which is not terribly satisfying. There's some in the book that, you know, they kind of got them so that, you know, the numerators cancel and things like that. But this is all that's really happening here, is that you might expect to have equations that have different values for the angles, right? And there isn't some formula, there's not some identity you use here. You just simply evaluate them and then perform arithmetic operations on them. Like I said, for some reason, when people see those problems, not everyone, but several people in the past, they have these kind of weird reactions to that. I'm not really sure what I'm supposed to do there. So there's your insight. Okay, so what else do we want to do with this stuff? It turns out that there's one other kind of key aspect of this that we can introduce right now, and it's sort of a strangely worded problem. So let me kind of give you a couple of examples to set the stage, and then we'll talk about how to find the answers. Okay, so my document camera's a little bit twisted there. Okay, so let's start by this statement. Find all angles theta in the range 0 to 360 degrees, for which Let's try a couple. How about sine of theta equal to negative root 3 over 2? Let's try another one. How about tangent of theta equal to square root of 3? And just to make it interesting, let's do one where we've got cosecant of theta equal to negative 2. Or instead of cos, let's make it secant, because I kind of want to, secant and sine are different enough. Okay, so what is this asking? All right. So when you're trying to solve a problem like this, you're basically getting to the point where you're almost about to take an inverse, where it's like, you know, you have what the angle, what the function is equal to, and so if you take the inverse function, you end up with the answer. Now that's something that we'll look at more carefully in coming sections, but this is not too challenging to approach. Here's the way to think about this. First off, forget about the well, just think about the value first. Is this value in the range of the function? So remember, sine has a range between -1 and 1 inclusive. So there are definitely some answers, right? There's at least one angle that this is true for. But it turns out that with almost every trig function, if you're only looking at between 0 and 360 degrees, and it doesn't happen to be one of the, you know, sort of special points that involve a quadrant angle, you can almost always find two angles that do this. So how would you go about doing this? Well, first, you'd want to be able to say, so sine of some reference angle is equal to square root of 3 over 2. So now you're trying to isolate it down to just quadrant 1. And so if you run through the exact values, you go, well, it's not 0, it's not 30 degrees, it's not 45, it's 60 degrees. So this tells you that theta prime is equal to 60 degrees. Okay? So there's the reference angle that corresponds to the magnitude of square root of 3 over 2. Now, unfortunately, this has a negative sign in front of it, which means that that's not a correct angle for the problem. However, there are two quadrants where sine of theta is negative, and that's in quadrant 3 and quadrant 4. So sort of like working the problem in reverse, you now have the reference angle, and you want to find the quadrant 3 and quadrant 4 answer that corresponds to it. So if we kind of look at those formulas and say, okay, well, how about in quadrant 3, I know sine is negative, and as you recall, the equation that I had written was that the reference angle is equal to the angle minus 180 degrees. So this tells us if you have the reference angle and want the actual angle, you have theta is equal to theta prime plus 180, which is going to be 240 degrees, right? 180 plus 60, 240 degrees. What about Q4? Well, remember the equation was the reference angle is equal to 360 degrees minus the actual angle. Now we have to be a little careful here with the SIGN. So if you do a little bit of manipulation here, this comes out to theta is actually equal to 360 degrees minus theta prime. And so 360 minus 60 is an angle of 300. Now, if you look at the way these things are written in the textbook, they use this set builder notation. So rather than just like kind of circling this or boxing it or something, the way that they like to see the answers produced is that theta is a member of the set that contains 240 degrees and 360 degrees. Now, usually this is what they're looking at, but this specifies what is equal to where does these things come from. So you could think of it, you know, maybe you saw this in an algebra class previously. That's the solution set to the problem. This is just saying that the variable in question has to come from that set. Either way, I mean, really, the only thing that I'm hoping to get from this set builder notation is that you recognize the difference, because we will get to things that require more complicated looking sets. Okay, so this may have been kind of a challenging thought. Let's go back and try the one for tangent. So kind of in the same sort of vein, right? Where does we need to kind of think about, well, where does, in the first quadrant, what reference angle corresponds to a tangent of that angle equaling square root of 3? Well, it turns out, if you run through it, it's not 0, it's not 30, it's not 60, it's not 45, it's actually 60, just like this one. So the reference angle is equal to 60 degrees. Where now we're wanting to ask ourselves, since we're looking at tangent being positive, we want to find the actual angle that corresponds to the two quadrants where tangent is positive and has a reference angle of 60. Now, one of them is quadrant 1. So quadrant 1, theta equals theta prime. There's nothing to really be done there. So we have theta equal to 60 degrees. In quadrant 2, and the other quadrant where tangent is positive, remember all students take classes, is actually quadrant 3. So remember in quadrant 3, and I'll just appeal to the equation we already had up here, we just add 180 degrees to the reference angle. So theta is equal to theta prime plus 180 degrees. So theta is equal to 240 degrees. So again, to kind of use that set builder notation, and maybe I'll just, this is about all I want to finish the one problem, but I don't want to start a whole new page. I'm going to cramp it here a little bit. So theta is in this set that contains 60 degrees and 240. There's your two values. So finally, let's look at the one involving secant of theta. Now secants can be a little bit more challenging. So equal to -2. Now, my suggestion, because I'm not really as proficient at remembering what the exact values are for secant per se, but I do remember what it is for cosine. So I just usually make the conversion. I just flip all these upside down. This tells us that cosine of the reference angle is equal to -1/2, or sorry, +1/2, right? And we're going to have to use the positive value. So there's the reference. Where does that occur? Well, I mean, this is just kind of a coincidence, but the reference angle has been 60 degrees in every one of these. I just pulled these out of thin air, so that wasn't really intentional. But we're going to end up with the same situation where the reference angle is equal to 60 degrees. So now you have to ask yourself, where in what quadrants is secant equal to, is secant a negative number? And remember, that's all students take classes. Secant is determined by what cosine does. Cosine's positive in quadrant 1 and 4. It's negative in quadrant 2 and 3. So there will be one solution in quadrant 2, and the quadrant 2 solution, which I don't think we've done that one yet. Here was the original equation. Theta, the reference angle is equal to 180 degrees minus the angle in question. So this translates into the angle in question is equal to 180 degrees minus the reference angle, which is just 120. And since we've already done this several times, quadrant 3 with a reference angle of 60 degrees is just simply this 240 here. So maybe I can just say from above, theta equals 240. So when we write the solution set, theta will be coming from the set that contains 120 and 240. And I think those solve the problems. So these aren't terribly difficult trigonometric equations. We're going to practice these over the coming weeks, and then once we get to essentially the last chapter of the book, chapter 6, the last major course unit, we'll be looking at this sort of thing in much more detail. But for now, this is a skill that you should be able to do, and you might even expect this on the upcoming test. So with that said, I will leave it there, and I will see you again after the exam in section 2.3.